Started. Thanks everybody for joining us. Welcome to Breaking Down Forever Chemicals. My name is Lori Epstein. I am the Water Quality Director with Columbia Riverkeeper, and I'm so excited that you're here with us today. Thanks so much for joining us. Today we're going to be hearing from Dr. Alyssa Cordner from the PFAS Project Lab and Megan Liu from Toxic Free Future to hear about forever chemicals, specifically PFAS, and the issues with them and what we can do about them. This webinar is brought to you as part of Columbia Riverkeeper's Love Your Columbia webinar series. And Columbia Riverkeeper is a nonprofit, and we're dedicated to protecting and restoring the Columbia River. And we offer these webinars as a free way to connect with our community and to help educate people on our watershed and the issues affecting our river. Personally, I've been with Columbia Riverkeeper for over 13 years. I'm a salmon biologist and I'm a parent to two young boys. And we swim in the river, we eat fish from the river, and I just care tremendously about the health of our river. And that's why I feel like talking about and learning about these issues, even the ones that are sometimes really difficult, things like toxic contamination, is so incredibly important. If these are issues that also feel important to you, one of the best ways you can support this work is by becoming a member of Columbia Riverkeeper. You can do that with a one-time donation or a recurring contribution, but it really helps us to support this work and continue to do this kind of work. I'll be sure to put a link in the chat so people can learn how to do that. And I also would encourage you to support the work of PFAS Project Lab and Toxic Free Future. They're doing really important work on these issues as well. And before I introduce today's speakers, I'd like to start with a couple of announcements, starting first with a land acknowledgement. We at Columbia Riverkeeper recognize the unique and enduring relationships that exist between Native people and their traditional territories. We respectfully acknowledge the places that we're joining. Today's webinar from rest on traditional lands of Native people who have cared for these lands and water since time immemorial and continue to do so today. I'm joining from near Columbia Riverkeeper's office in Hood River, which rests on the traditional lands of the Wasco-Wishram, Warm Springs, and Yakima Nation. So to learn more about the Yakima Nation and other Columbia Plateau tribes, definitely encourage you to visit the Tribal Nations websites and the Columbia River Intertribal Fish Commission website as well. This webinar is part of Columbia Riverkeeper's Columbia Gorge Pollution Prevention and Education and Outreach Project, which is funded by the EPA through their Columbia River Basin Restoration Funding Assistance Program. It's a grants program for environmental protection and restoration programs throughout the Columbia Basin that provides funding for toxics reduction, monitoring, and education actions as well. So this webinar has been funded by the United States Environmental Protection Agency under an assistance agreement to Columbia Riverkeeper, but the contents of this webinar do not necessarily reflect the views and policies of the Environmental Protection Agency. So thank you, EPA, for your support of this webinar and our programs. We really appreciate it. And one other supporter of this webinar was Green Oil. They make plant-based, 100% fully biodegradable bicycle lubricants and that are completely free of all polyfluorinated chemicals. And bike lubricants are a common source of PFAS, as we might hear today, but Green Oil donated a couple of bottles of their completely PFC-free bike lubes. So we will be announcing a winner at the end of that. So thank you, Green Oil, for that donation. And one last bit of housekeeping is after our speakers, we will leave a little bit of time for questions and answers. So please save those. You can feel free to type them in the Q&A and we'll come to those at the end. And we anticipate that this might be an ongoing conversation so we can share contact information as well if we're not able to get to all of the questions, but we'll do our best to do that. So with that, I'd love to introduce today's speaker. Speakers. We have Dr. Alyssa Cordner. She's the co-director of the PFAS Project Lab and an associate professor at Whitman College. She's conducted extensive research on the regulation, science, and activism related to industrial chemicals. We're so excited to have Dr. Cordner with us today. And we also have Megan Liu. She's the Science and Policy Manager for Toxic Free Future, where she manages their science projects and policy initiatives. So Megan, we're really excited to have you too. Thank you so much for joining us. And with that, I will turn it over to Dr. Cordner.
Great. Thank you so much, Laurie. It's really wonderful to be here today. I'm here in Walla Walla, which is the homeland of the Cayuse, Umatilla, and Walla Walla peoples, who are part of the Confederated Tribes of the Umatilla Indian Reservation. As you said, I'm an associate professor here at Whitman College, which is in Walla Walla, and I also co-direct the PFAS Project Lab, which is an interdisciplinary research group based at Northeastern University. Can folks see the slides? Okay. I guess let me know if you can't. I can't see anyone's faces, but let me know if you can't see what you need to see. We are a mostly social science based organization. I'm a sociologist. The co-director, Phil Brown, is a sociologist as well. But we have, as members of our lab group, folks ranging from environmental toxicologists to epidemiologists and other social scientists as well. And we work with a number of community partners on our work, which has been going on. We've been working on PFAS since 2014. And one of the major things that we do as something that serves the public is a publicly available website, pfasproject.com. And this website has a sort of roundup of daily news stories, a whole lot of resources, ours, but also links to other resources from a bunch of great organizations. You can sign up for our newsletter there. It comes out about every 2 months. And you can also get links to a lot of the projects, some of which I'll talk about today. So I'm guessing that many of you have heard of PFAS, or at least are PFAS curious. And so why are we talking about this class of chemicals? I'll give a really brief overview for what PFAS are, why we think that they are a major concern for human health and the environment. We could do many hours just on the PFAS background. So I'm going to go quickly through this, but I'm happy to answer questions at the end. So PFAS are a really broad class of chemicals, per and polyfluoroalkyl alkyl substances that are defined by their chemistry. And the EPA, the US EPA, estimates there are about 12,000 chemicals in this class. So this is a huge number of chemicals. Most of the attention has focused on a couple dozen, and beyond the few that are pretty widely studied, there are a lot of PFAS that we know relatively little about, but that still seem to be concerning in terms of human health and the environment. We are exposed to them through many different exposure pathways, and as a result, they are pretty ubiquitous in samples taken of human body tissues. For example, the Centers for Disease Control and Prevention found PFAS in close to 100% of the blood samples they took as part of a national biomonitoring study. These chemicals are especially concerning because they are both extremely persistent and they're highly bioaccumulative. So they're persistent, meaning that they don't break down readily in the body or in environmental media. And they're bioaccumulative, meaning that we can end up with higher and higher levels of them in our bodies. That persistence and bioaccumulation potential becomes a problem when we are exposed to them all the time through countless consumer products, as well as sources that might come through drinking water, food, etc. So they're used in all kinds of consumer products, ranging from the really well-studied and widely known uses like nonstick cookware and waterproof clothing, but also things like ammunition, my current favorite, COVID-19 testing equipment. They're used in all kinds of things that matter in our daily lives. But they're also used in literally hundreds of different types of industrial uses, ranging from wire and insulation cabling, the manufacture of textiles, paper products, fracking fluids. They're just used in all types of industrial applications. They're also very widely used in certain types of firefighting foam, Class B firefighting foam that is designed to extinguish flammable fuel fires. So think about, for example, if a an oil fire on a submarine catches fire, you would use a Class B foam, or a fire at an airplane fire, you'd use a Class B foam. And currently in the US, the only Class B foams that are approved at the federal level contain fluorine. They're really, really widely used. And again, because they are so persistent and because they are very mobile in the environment, in particular mobile in water, we end up with contamination that's very widespread. I really like this sort of exposure pathway model that comes from the epicenter of the AAAS, and it shows that we can be thinking about exposure coming from surface and groundwater, but also coming from wastewater treatment plants, incineration facilities, all the sort of ways in which we cycle waste through our environment. You end up finding PFAS in those places. And that means that we can end up with both point source contamination, so contamination linked to particular places, but also non-point source contamination. A recent study looked at measured PFAS levels in rainwater and found that the levels in rainwater samples are higher than health-based guidelines developed by multiple regulatory agencies around the globe, suggesting that PFAS are a problem not limited to folks near a contaminated site, but are actually a concern for the entire globe. We know that exposure in drinking water has been really well studied. I'd say that's the exposure route that we know the most about. And it's the exposure route that, and we know that there's a lot of exposure through this exposure route. So a study by Andros and Idenko estimated that over 200 million US residents receive PFAS contaminated drinking water from their public drinking water source. There's also no federal regulation for PFAS under the Safe Drinking Water Act at this point in time. The EPA did in June release health-based advisory levels that were quite a bit lower, were thousands of times lower than their previous health advisory levels. But these levels have no legal enforcement yet. The EPA, the federal EPA, has announced their intention. They're in the process of developing these MCLs, but we're waiting to see what those levels will be. A number of states have enacted stronger protections, some of them in the low teens in terms of parts per trillion for PFAS, but there still is very uneven coverage across the country in terms of PFAS protection in drinking water. And we're concerned about exposure to PFAS because that exposure is linked to a number of significant health impacts. So this diagram here from ECHA shows shows impacts to the development of fetuses and babies, as well as to the developing system, and then impacts to multiple organ systems in the adult body. Dr. Linda Birnbaum, who is the retired and former director of the National Institute of Environmental Health Sciences, suggests that PFAS impact so many organ systems, and they do so consistently. So certainly the chemistry between individual compounds might differ a bit, but we see very consistent health impacts across these different PFAS chemicals, and they are impacting human health in a variety of ways. So links to liver impacts, multiple types of cancer, thyroid impacts, immune function response measured in terms of things like decreased vaccine response, and then developmental effects, as I said. So there are lots of concerns about PFAS in terms of human health as well. We also have significant concerns about PFAS in terms of environmental inequality. And I'll just mention a couple studies that we have ongoing in our lab. So a paper that's just been accepted at EHP looks at how tribal communities' drinking water sources are disproportionately excluded from federal PFAS testing efforts. We have another study that is close to being resubmitted, looking at how people of color and low-income populations are disproportionately exposed exposed to PFAS contaminated drinking water in the state of New Jersey, which has they had the earliest PFAS MCLs, and so they have the most data that covers the entire state, making them a great and early place to look at environmental justice issues related to PFAS in drinking water. And then another paper that's under review looks at the proximity of PFAS contamination sites to carceral facilities across the US, including adults and juvenile jails, prisons, and detention facilities, and finds that about half of those carceral facilities are proximate to a source of likely PFAS contamination. What do we know about where PFAS are located? Well, our lab has been maintaining the PFAS contamination site database, or our tracker, as we call it, since about 2017. We started at that point with just a couple dozen sites that we knew to be PFAS contaminated, and at this point we have over 1,700. These are specific sources of PFAS contamination. So, for example, the Environmental Working Group has a great map of drinking water detections, but that's different than the purposes of our site, of our map, which is about identifying sources or locations of the contamination. So, for example, a landfill, an airport, an industrial facility. And as I said, we have about 1,700 of these sites. Here's a map of where those sites might be. And you'll notice that they are not evenly distributed across the country. That's because testing has been so uneven across the country. So if you zoom in on a couple locations, the map, if you look at the map on the upper left, it would seem that there's basically no contamination if you leave Minnesota and just go right over the Minnesota border. I don't know if you can see my cursor, but if you can here, oh my gosh, there's no contamination right here in Iowa. But that's actually just because Minnesota has done a really great job testing for PFAS. Same thing in New Hampshire. It looks as though all of the contamination in New England is located in New Hampshire. Well, that's just because New Hampshire has done the most systematic testing. So what we've argued in publications is that known sites of PFAS contamination is a huge underestimation, and it really represents not where the contamination is, but where testing has been done. If you test for PFAS, you are likely to find it in many different types of media. And so before handing it over to Megan to talk a little bit about some specific things happening in the Northwest, I want to mention a paper that we just had come out a couple of weeks ago, which looked at presumptive PFAS contamination. So if you don't have high quality testing data on where PFAS contamination is likely to be, say you're in a place like Washington or Oregon that hasn't done the same type of site-based testing that places like Minnesota or New Hampshire have done. Where should you think about looking for PFAS contamination? And we have this model of what we call presumptive PFAS contamination. So in the absence of high quality data, we argue that PFAS contamination should be presumed around 3 types of sites. Locations where fluorinated firefighting foam has been discharged, that's the AFFF, the aqueous film forming foam. So places where these foams have been discharged, whether that is for training or testing by fire departments, or whether it's for putting out fires, that we should presume that those sites have PFAS contamination because AFFF is really highly contaminated with PFAS. Well, not contaminated, it is, PFAS is an intentional ingredient in AFFF. And these chemicals are so persistent in the environment, even if those foams were sprayed 2 decades ago, you would still find very high levels. That's the first category of presumptive sites. The second are certain classes of industrial facilities. And to identify which types of industrial facilities, we assembled 11 different academic or regulatory studies or processes that had linked PFAS contamination with particular types of facilities. And we identified 38 different industrial classifications that appeared in at least four of those lists. to try to develop a model that is appropriately, we might say, conservative enough that it could be used by, say, a regulatory agency that really wanted to prioritize scarce resources. So that led us to these 38 industry classification codes that we identify as presumptive sites of contamination. And then the third category of facilities is sites related to PFAS-containing waste. And this might be wastewater treatment plants. This might be places where landfill leachate is an issue, might be places where sewage sludge has been applied to agricultural land. So we have these three categories of sites. We map as many of those as we can. In this figure here, that's the observable category. These are things that we can map, but many things we can't. So there is no nationwide database of sludge application sites. There's no nationwide database of firefighting training facilities. So these are things that are part of our model, but we don't have nationwide data on. And so this map, here's the nationwide map, identifying about 57,000 presumptive sites of contamination in the US. We validated this model by looking at states with the most PFAS contamination and states at the median, and then counties in both places, trying to identify whether known contamination sites from our database were captured in our model. And we found that 72% of them were. Our presumptive contamination model, as I said, is a little bit cautious. We really want to identify not just possible sites, but probable sites. And I'm happy to talk more about that in Q&A if folks are interested, or the whole paper is also available open access, published through ES&T letters. We think this model has a lot of potential utility for folks working in the PFAS space who might be struggling with the same issues that we have been thinking about in our lab group. How do I know where contamination is if we don't have good testing data? And so we hope that it allows regulators, researchers, residents, and other decision makers who might want to do some prioritization, who might want to know about hotspots of PFAS contamination, to identify these locations for future action. We also think there's a lot of future work that can be done on the research side. Things like adding some sort of weighting. So maybe if you are, near an industrial facility that is producing PFAS, that's probably more of a concern for direct exposure than, say, a wastewater treatment plant, where you don't have probably airborne emission of PFAS into the environment. This also could be used to, for example, link up proximate PFAS, presumptive PFAS sites with things like tribal lands, with environmental justice communities, with parks, with intake locations for public water utilities. So we think there's a lot of utility there as well. We're also working on a lot of different projects related to PFAS governance, activism and advocacy, trying to understand the development of research, trying to understand the barriers that are facing more precautionary and public health oriented regulation, and trying to understand the inequitable consequences of PFAS exposure. So I will end there. I'm happy to take questions after Megan's presentation. My email is also up here, and happy to talk to folks over email after as well. So Megan, I will turn the screen over to you.
Thanks so much, Dr. Cordner. I'm going to share my screen really quickly. Okay. Alrighty, so hi everyone, my name is Megan Liu. I am located in Seattle, which I would like to acknowledge is the land of the Coast Salish, specifically the ancestral land of the Duwamish and Squamish. I am the Science and Policy Manager at Toxic Free Future, and I'm here to talk today about PFAS research and regulation that is going on in Washington State. And so just to further introduce ourselves, Toxic Free Future is a national organization based in Seattle. We were founded in 1981, originally working on local environmental justice issues. We've now expanded to not only doing research and policy work in Washington, but also have arms of our organization working in federal policy and towards market transformation. Through our research, we are able to drive strong laws and corporate responsibility to protect people from exposure to toxic chemicals. But not only do we want to just get rid of toxic chemicals, we also want to drive government policy and markets towards safer products. As for primary concerns with PFAS, I won't go into this slide too much, but like Dr. Alyssa Corner mentioned, PFAS are a class of over 12,000 chemicals that are really persistent, mobile, and toxic. They're the chemicals that have the strongest bond in organic chemistry and have no known environmental degradation, hence why they're known as forever chemicals. They're really soluble in water, as mentioned before, and can move through soil to groundwater. This image here shows areas across the United States where PFAS has been detected in drinking water at levels above the EPA health advisory levels. About 6 million US residents have had their drinking water contaminated above advisory levels, but as just mentioned, these levels aren't regulated and testing also isn't completely adequate. So that's really concerning with all of the concerns there are around PFAS and its toxicity, and it's associated with cancer and immune system effects. I will also mention here that there's a very small number of PFAS that have been phased out, and there's still many PFAS chemicals that are being used globally. So with PFAS being so highly persistent and mobile, there is widespread contamination. This weekend, a big article came out in the Seattle Times on how PFAS that was being used decades ago in firefighting foam at the Army's Yakima Training Center was found in well water in Yakima, making the water in surrounding communities undrinkable. For some homes near the positive wells, residents are receiving weekly deliveries of bottled water for drinking and cooking. However, many residents are left still looking for solutions. And this diagram is also similar to what we just saw, but as mentioned, PFAS has a lot of exposure routes throughout its entire life cycle. Starting from production and manufacturing, there's been severe contamination of PFAS in communities near facilities and in workers. And when products are used, consumers then become exposed through house dust and indoor air. At the end of life, these products can go to landfills and incinerators, becoming an ongoing source of contamination. So what research has been done in Washington? Here I'll mention a report that the Washington Department of Ecology conducted, which is a state agency that has been key in identifying and regulating toxics in Washington. So in 2016, the Department of Ecology released a report where they surveyed PFAS chemicals in rivers and lakes throughout Washington. In the study, Ecology collected and tested osprey eggs from nests in 8 locations along the Lower Columbia River in 2008, and then they collected eggs from the same locations again in 2016. PFAS was detected in all of the eggs that they collected from both years. And you'll see here in this chart that PFAS actually increased from 2008 to 2016 in some of the locations. But then you'll also see in some of the locations, PFAS levels decreased from 2008 to 2016. So overall, what the study showed was that PFAS bioaccumulates and was persistent 8 years apart in wildlife along the Columbia River. And so now I'll move into research that Toxic Free Future has conducted. In 2021, we did a study on PFAS in breast milk. We wanted to learn more about breast milk as it's one of the most important sources of nutrition for babies. And we also wanted to look at PFAS levels in moms during gestation. We were really interested in early life exposures since they can lead to adverse health effects, and breastfeeding is a really important early life exposure pathway. This was the first study since 2004 to look at PFAS in breast milk in US mothers. So we wanted to find out how levels of PFAS in breast milk have changed in the US in the past 15 years since the 2004 study, and to see if current use PFAS were present in the breast milk of women. So we recruited 50 first-time moms living in and near Seattle, Washington in 2019 to provide breast milk samples. And what we found was that PFAS was detected in all of the samples. In total, 16 types of PFAS chemicals were found, and all samples had at least one type of PFAS. In more than 50% of the samples, there are 12 types of PFAS detected. More specifically, the types we found included PFOS and PFOA, as well as long-chain PFAS and short-chain PFAS. In this chart right here, you'll see the PFAS concentrations that were detected. These ranged from 50 to over 300 picograms per milliliter. And then you'll see here that most of the samples were in the 100 to 300 picograms per milliliter range. For more context, current use PFAS detections have been doubling globally every 4 years, and these results were the first to show that short-chain PFAS can bioaccumulate and demonstrated that current use PFAS are building up in bodies and breast milk. The PFAS that we found in the study are also the same types of PFAS that are commonly used in items like food packaging and textiles. And so overall, we learned that breast milk is an important source of exposure for PFAS. And in the study, we found levels that were higher than what we expected. So regulation is really important to safeguard pregnancy and breastfeeding and in preventing babies from developing adverse health effects later in life. More specifically, it's really important to regulate chemicals by classes, as in the past, industry has argued that PFAS doesn't build up in bodies, but this study showed otherwise, and that PFAS chemicals truly do build up in bodies, namely in women's bodies during pregnancy. This is not a light issue, as babies are being exposed to PFAS from birth, and the findings from the study have helped lead to regulation on PFAS, which I will go into more towards the end of this presentation. So to learn more about where PFAS was coming from, in 2021, we did a study called The Path of Toxic Pollution, where we did a deep dive into the only plant in the United States that was producing PFAS for food packaging. This report traced the path of American PFAS in food packaging back to one manufacturing company, Daikin America, which is located in Decatur, Alabama. And Daikin's manufacturing of PFAS for food packaging has contributed to drinking water contamination throughout North Alabama. This here is a quote from Brenda Hampton, a community member in Decatur, and it reads, "Members of my community have been drinking poisoned water for decades because of plants like the local Daikin America facilities. No one's drinking water should be poisoned to make burger wrappers." PFAS has been detected in blood samples from local residents in the area, and the pollution of drinking water has become a large environmental justice issue. The community within 3 miles of the Daikin facility is majority African American, and the majority of the population makes under $50,000 a year. And so while we found that Daikin's production of PFAS is harming communities, it is also negatively impacting the climate. HCFC 22 is a basic building block for making PFAS and is also a potent greenhouse gas and ozone depleting chemical. For context, it's 5,000 times as potent as carbon dioxide, and Daikin has reported releasing more than 200,000 pounds of HCFC 22 a year. This makes Daikin the nation's #2 polluter of HCFC 22, and their emissions are equivalent to emissions from driving 125,000 passenger cars for a year. And so we've also been able to do research on products in which PFAS is used and investigate how people are exposed. We've done a couple of studies on food packaging and textile products, but starting with food packaging in 2018, we did a report called Takeout Toxics, where we tested food packaging from top grocery chains for PFAS. PFAS are used in a lot of different types of food packaging, either as a surface treatment on things like a cookie bag or a burger wrapper, or sometimes they can actually be mixed into the paper. Mixing PFAS into paper is the method that is used to make molded fiber clamshells, which is a type of product that you can see right here in this photo. And this is actually concerning because it means that they actually have higher levels of PFAS due to the paper mixing process. And so why that is also concerning is because we think that these items are compostable, but in reality, they actually contain PFAS and are potentially contaminating our soil. And the reason why PFAS is used in food packaging is to provide oil and grease resistance, but then this can lead to PFAS leaching out and getting into food, people, compost, and the environment. So in this report, we looked at 5 of the nation's largest grocery chains to see who was using and selling food packaging containing PFAS. And the products that we tested were store brand items, all of which were food contact materials. They included things like containers, food wrappers, plates, and trays. And the items that you see here at the bottom of the slide are the items that contain PFAS. And while we found PFAS in 10 of the items tested, a large amount of the products that we tested were actually PFAS-free. So the results really helped highlight opportunities for retailers to phase out PFAS and switch to safer alternatives, which I will also elaborate more on in a few more slides. And as a follow-up study a couple years later in 2020, we conducted another study called Packaged in Pollution. This time we tested more food packaging, but from major fast food chains. And so we collected 29 food packaging samples from 16 locations across 3 states and from a total of 6 different fast food chains. The chains included Burger King, McDonald's, Wendy's, and Sweetgreen. Food packaging items we tested included packaging used for burgers and sandwiches, fried items and desserts, and salads. And so what we found was that nearly half of all food packaging samples tested positive for fluorine, which is a compound that indicates presence of PFAS. You'll see in this chart that at least one packaging item from every burger chain appeared to be PFAS treated. This study was really important in that the results allowed us to work with retailers to take action on PFAS. After the study, Sweetgreen and Chipotle phased PFAS from their food packaging out by 2020. In 2019, Ahold Delhaize, a major grocery chain that includes brands like Stop & Shop and Food Giant, announced policy to go PFAS-free and actually work with Toxic Free Future in 2020 to expand supplier testing requirements to get PFAS out of their materials. We also campaigned to get McDonald's to phase PFAS out of their food packaging as well. Here are a couple of photos of the petition we had urging McDonald's to take action. And it worked. In 2021, McDonald's announced a new global sustainable packaging commitment banning PFAS from packaging materials. And so while the presence of PFAS throughout products might be intimidating, research is being done and it is essential to get markets to move towards safer solutions. Through our work, we have convinced food giants like McDonald's, Burger King, and Whole Foods Market to eliminate PFAS in food packaging at more than 140,000 locations worldwide. And while we have gotten wins, there's still a lot more to do, such as with textile work, which I'll now move into. And so the last piece of research I'll cover today before going into policy that is going on in Washington is our toxic convenience report, where we tested textiles to see if they contain PFAS. In textiles, PFAS is used for stain protection and water resistance, mainly as a surface coating. And when they're used in textiles, PFAS can actually shed from products over time and build up in our indoor environment. PFAS is also known to get into laundry water, which leads to contamination of our waterways. And so we selected 20 products from 3 product categories: outdoor apparel, bedding, and tablecloths and napkins. We did online purchasing from 10 major retailers, including Amazon, Bed Bath & Beyond, Costco, Dick's Sporting Goods, Kohl's, Macy's, REI, Target, TJX, and Walmart. And we mainly chose items that were advertised as stain or water resistant. And so what we found was that PFAS are commonly used for stain and water resistance. PFAS was found in 72% of the items labeled as stain or water resistant. And while the majority of the products we tested did have PFAS, the good news is that there were PFAS-free items in each category. Here you'll see 2 different types of REI pants that we tested, one that had levels of PFAS and one that did not. So all to say, there are alternatives to PFAS that are in use. And this research has also contributed to market action. And in this diagram here, you'll see some of the companies that have phased PFAS out of their products by 2022. Those brands include brands like IKEA, Zara, Levi's, and UGG. And then on the right, you'll see some additional retailers that have begun the goal of phasing PFAS out by 2025. Some of those brands include Columbia, Gap, American Eagle, and Osprey. And one of the ongoing campaigns that we have at the moment is getting REI to phase PFAS out of their products. As a national brand that is headquartered and popular in Washington, we hope to see REI move towards safer ingredients to protect their consumers. Over 130,000 consumers have signed a petition urging REI to take action. Okay, so in this last part of the presentation, I wanted to point out some key pieces of regulation going on in Washington state. Washington is leading the nation in strong policies in phasing out PFAS to protect people, especially vulnerable populations. We were the first in the nation to ban PFAS in firefighting foam and food packaging, and both of these bans were passed in 2018 and were ultimately followed by legislation in other states. After Washington banned PFAS in firefighting foam, congressional action followed to stop requiring PFAS-containing foams and also make the military phase out use of PFAS in firefighting foam. And then as for food packaging, there's currently legislation on banning PFAS in food packaging nationally, and that bill is sitting in front of Congress right now. And then another key piece of legislation in Washington is Safer Products for Washington. This was a precedent-setting piece of legislation that was passed in 2019 and will ultimately help stop the use of thousands of chemicals in millions of products by addressing chemicals as classes. It tackles high priority chemicals and every 5 years evaluates what priority chemicals and what products they can be found in to be regulated. This legislation will protect people and the environment from toxic pollution, and it gives the Department of Ecology the authority to ban, restrict, or require disclosure of chemicals and products, and ultimately shift towards safer ingredients in consumer products. And then this slide here shows the first priority chemicals and the products they can be found in that are being regulated during this first cycle of Safer Products for Washington. To save time, I'm not going to go into too much of these, but the law is currently addressing PFAS in carpet and rugs, aftermarket stain and water resistance treatments, and leather and textile furnishings. And Washington continues to lead the way to phase PFAS out of their items in the state. PFAS is so hazardous that we were able to get the legislature to speed up the timeline for regulating additional products under Safer Products for Washington. So new legislation was signed in March of this year that sped up the timeline for regulating PFAS. And by 2025, PFAS will be phased out from products, including apparel like raincoats, cosmetics, and firefighter personal protective equipment. As for other recent policy developments in the EU, there was a proposal to ban all non-essential uses of PFAS. Maine banned all non-essential uses by 2030. California also had a recent ban on PFAS in most clothing and textiles by 2025. Colorado has banned PFAS in a number of areas, all within the next few years. And then in other states, there are PFAS textile policies that are currently being considered. And so to end off with some recommendations for policymakers, you'll see some of our recommendations here. These are some of the guiding principles that guide our work on PFAS, and there's still, just to paint the picture, a lot of PFAS being used out there. And while we work to turn off the tap on PFAS, we also need to make sure communities who are exposed to PFAS in their soil, water, and air are getting relief. So we recommend policymakers to end all uses of PFAS when safer solutions are available, and to pass policies that require ingredient disclosure, restrict the most dangerous chemicals, and identify safer solutions, ensure the cleanup of contaminated communities, and hold polluters financially responsible, and then use governmental purchasing power to avoid products containing PFAS and spur the movement towards safer solutions. And so lastly, what you can do on an individual scale, you can call on retailers to get away from PFAS containing products. If you'd like, you can also check out our retailer report card where we rank retailers on their chemical policies. The website is linked here on the slide, and you can see retailers' actions that they've taken to eliminate toxic chemicals from their products. You can also make your voice heard with elected officials and government agencies. Again, the Department of Ecology in Washington is doing a lot of work on PFAS. They're going to have a public comment process for Safer Products for Washington and their PFAS-specific work. So if you go to their website, you can find out more information there. And then for food packaging, we have an online link where you can contact your senators and urge them to vote for the National Food Packaging Bill. Additionally, you can try to avoid buying apparel and home furnishings that advertise stain resistance. And if you do need to get water-resistant apparel, try to look for PFAS-free. And that's it. Thank you so much for having us. If you're curious about our work and would like to learn more, you can visit our website at toxicfreefuture.org. We also have a newsletter that you can sign up for through our website, and are also on Facebook, Twitter, and Instagram if you would like to follow us. Lastly, here, I would like to introduce my colleague, Erica Schrader, Toxic Free Future's Science Director, who is lead on many of the research projects that I went over today. She and I will both be available to answer any questions if you have any, and thank you so much.
Thank you so much, Dr. Cordner and Megan. That was really helpful to hear and learn about this. Just a reminder to everyone, you can feel free to put questions in the Q&A. We do have some time left for questions. Just to start, I would love to ask, you mentioned some of these products that there are great alternatives that don't have PFAS in them. And I was just curious if you have a recommendation of, is looking for something that says PFAS free, is that enough? Or is that, I'm thinking back to like when things would be advertised as BPA free. And then we sort of learned actually some of the BPA free things were just had a, regrettable alternative. So is looking for PFAS free, is that enough? Or is, do we need to be careful with that labeling?
I mean, it's so hard to say because like with the BPA study, it showed that what we thought was wrong. I think from what we found, really the most that what we can do is try and see, like opt for the PFAS free, because typically that means that these items don't have that surface coating on them. And so that already is preferable, since that's really what the issue is the PFAS on the outer layer of your jackets. And that's what gets into your indoor air and into the laundry water.
And one thing to look out for is items that just say PFOA free or PFAS free, because that's a clear indication that they, may have eliminated some of the PFAS, but are probably using other ones.
Thanks. I'll just jump into the Q&A here. Somebody asked, can we recycle the clamshells? I think they're referring to the food packaging, since they have PFAS. I know the presenter said they are not compostable.
I can give a little more background on the compostable containers too. So as Megan said, the typical compostable, molded fiber containers for many years were made with PFAS for that stain and water resistance. But the organizations that actually provide certifications for compostability in the last couple of years have restricted the use of PFAS. So if they're certified compostable, they should not have PFAS in them. But that doesn't mean if you get your food in a molded fiber container at this point that it's definitely PFAS free, because I think that the market's transitioning, and probably there are some out there that are not certified compostable. At any rate, they wouldn't be recyclable. But you can check for compostable certification by either BPI or Cedar Grove. Those are the ones that prevent the use of PFAS.
Thanks, Erica. The next question, what steps do you suggest Oregon should take to address PFAS? What can nonprofits do to encourage this?
I would say, again, similar to the policy suggestions that we had, just to also follow suit with other states. I'm personally not as aware of what policies are ongoing in Oregon right now, but to just pass policies to end the use of PFAS. If they haven't banned it in firefighting foam, that could be a good place to start. And then also to follow suit with food packaging bills as well. And overall, I think it's just important to have policies that just ultimately end the uses and require ingredient disclosure when it's possible, and make sure that action is being taken to clean up contaminated communities.
Thank you. Let's see, somebody, is anyone tracking the increase of cancers and other illnesses that can be linked to PFAS pollution? What is the worst effect of PFAS, which would be the most likely illness that could be tracked?
I'm not sure I can answer that specific question. However, I would point folks, the National Academies just released a guidance document on PFAS health impacts and suggestions for medical screening. That is a really thoughtful and systematic evaluation of many different health endpoints linked to PFAS exposure. I can put the link to that in the chat in a minute, but I think that document is really useful in terms of identifying specific health endpoints, a couple different types of cancer, different developmental or liver effects, that kind of thing. And then it also says, if you're in a sort of a background level where maybe you don't have a really known intense source of PFAS contamination, here are things for you to think about. If you've been drinking PFAS contaminated drinking water and you know you have quite high levels of PFAS in your body, what are some additional medical screenings that you need to talk to your physician about? So for example, if you have higher levels of PFAS in your body, maybe you want to have more regular cholesterol screenings. Maybe you need to have more regular thyroid screenings, that kind of thing. So that document is very useful, and I'll find the link and put it in the chat.
Thanks. This kind of leads into another question that Dr. Corner, I think you answered in the Q&A already, but somebody asked if there are tests for PFAS that the average person could obtain to test local streams, your tap water. So maybe kind of thinking environmental exposure, but also potentially, you know, assessing your exposure in your home. Is that a possibility?
The answer I put in the chat is it's very expensive. This is why the solution, as Megan noted, is that we need to stop ongoing and new uses of PFAS in virtually all situations, because once PFAS is out there in the environment, it will make it into exposure pathways that we all come into contact with every day, like our drinking water and our food systems. And so the thing that is needed to stop exposure is ending the use of PFAS and decreasing the sources of exposure. There are some labs that do testing. I think someone else had put later on in the Q&A a link to a lab that either they've been working with or they know has been doing some testing in Oregon. And I put a link in the answered Q&As. There's a link to a lab testing database that Washington State has, or if you put in the specific lab number, it's not accessible. It's not something like I can go to the hardware store and get those little sticks for lead testing where you just push it up against lead paint and it turns bright pink. There's nothing like that for PFAS. You know, for a lot of reasons, but it's not accessible in that way. It's very expensive. It's hundreds of dollars a sample. And so I think we really need to see more broad systemic change.
Yeah, there's a few questions that are kind of circling around maybe kind of remediation or the ability, you know, the ability to remove PFAS from water. You know, are these things that can be system-wide in, you know, well systems or in your home? Is this something that we could do for drinking water, and kind of how feasible is the removal of it?
I'll put another couple links in the chat also. There is effective drinking water remediation technologies out there, both at the level of the home and, you know, of course, at the level of the drinking water system. At the home level, my understanding is that the systems that seem to be the most expensive are the under the sink charcoal-based systems. There were some studies that found that I think it was whole house reverse osmosis was actually not necessarily effective, at least in that particular study. And with under the sink filters, they can be very effective. They're hundreds of dollars, and you have to change the filters regularly. And if you don't change the filters, then they actually start to desorb the PFAS that they have taken out of the drinking water. And so that ongoing maintenance is absolutely essential. But there certainly are treatment technologies out there. They are expensive, and right now the burden is falling on individual consumers and on municipalities to pay the costs of this contamination, where it should be being linked back to the folks responsible for the pollution, to the chemical companies, or to, you know, it's often a military, or in many cases, it's a military base that's linked to drinking water contamination, or an industrial facility. So the drinking water treatment costs are not being distributed equally right now. And Megan and Erica, you might have more specific things to say about remediation also.
I can jump in with another question. Peggy asked, how do you get it out of your body if it's in you? And I know with many contaminants, especially these kind of persistent contaminants that live in our body, my understanding is, as a mother, actually breastfeeding is one of the only ways to get these contaminants out of your body. And so, which is kind of leads to, that being a large source for your child. I don't know if either of you could speak to this, or if this is, the case with PFAS as well.
Yeah, I can speak to it. So, a number of PFAS have just extraordinarily long half-lives in our bodies, like up to 12 years. So these are chemicals that once we're exposed, it's really hard they're going to be in your body for a long time. So that's why we're so focused on stopping the production of PFAS so we can reduce our exposure. Because once we have that exposure, it's really difficult to do anything about it. In terms of, other, natural ways that that our levels decrease, lactation is one, breastfeeding, but also women tend to have lower levels of PFAS because of menstruation, because these are chemicals that actually build up more in blood than in fat. So they're kind of unusual, persistent chemicals in that way. So, during menstruation, that part of your life, you will be reducing your levels in that way.
That's really interesting. Thank you. Brandy asked, can you speak to disposal of products and filters methods that don't further pollute?
It's really a challenge. There is really important work that's happening around things like drinking water levels that are enforceable and that lead to cleaner drinking water for everyone. Then the question is, though, what happens to the waste that is accumulated? There's an urgent need for disposal and destruction methods that are both effective and safe. My understanding, and then Erica and Megan, please correct me as needed. My understanding is that up to this point, the major methods have been landfilling, which is just putting that waste somewhere else until it can end up in the leachate, or incineration. But we know that incineration of PFAS, to destroy that very, very tight carbon-fluorine bond, incineration of some PFAS has to be at temperatures over 1400 degrees, which is well beyond the capabilities of your average neighborhood incinerator. There has been some movement to stop incineration of PFAS, for example, by, with military waste until there can be a little bit more research, but incineration is certainly not a solution for PFAS waste, especially because we know that across country and globally, incinerators tend to be located in already disadvantaged communities. There have been some kind of flashy scientific studies on ways to address PFAS waste that have a lot of promise, but also have some pretty big limitations in terms of scalability, in terms of involving some pretty nasty chemicals as important precursors themselves, and only really working with concentrated PFAS waste and particular types of PFAS waste. So we don't have good solutions at this point to the waste and waste disposal and destruction issue. And that again brings us back to the best thing we can do is to stop the ongoing use and stop new uses of PFAS. I mean, these chemicals are still incredibly widely used. One of the most maybe notorious PFAS manufacturing facilities right now, Chemours in the Cape Fear River Basin in North Carolina, is currently, they have a permit to expand their manufacturing. So even though there's such incredible, it seems like, momentum around restricting the use of PFAS, they are still seen as an opportunity area for the chemical industry. So I think that's where I see the bigger, we need the technology and the good regulations around disposal, and we need to be turning off the tap.
Yeah, thank you. I think that's a great, place to end with that. That's really helpful. Really appreciate everyone for joining us today. Thank you so much to Dr. Cordner and to Megan. Thank you also to Erica for chiming in with some of the questions. We really appreciate everyone joining us today. And, again, if this leaves you wondering, how you can support some of this work further, definitely encourage you to check out Toxic Free Futures and PFAS Project Lab. Consider joining in their work, maybe consider becoming a member of Columbia Riverkeeper as well.